Hello everyone. Today we will start modeling web post buckling of cellular beams. We are going to model and web post buckling. It is well-known phenomenon actually in the failure of cellular beams, and you can see the shape of web post buckling over here for one of the experiment. Uh, the dimensions for the web post buckling or the cellular beam, it mainly is the the opening diameter, the distance between the opening, which is S, the height of the opening, which is H, and also the thickness of the web, which is T0, the flange thickness, which is T0, the width of the web here, which is BF. Now, what we really want to do is we need to going to model. This is one of the research paper. I advise you actually to go through it and read it. And we are going to model the model A2. A2 here we're gonna model it numerically using finite element model abacus. Um, if you look over here, we have a cellular beam here. That is the cellular beam investigated experimentally, and the total length for that cellular beam is L. Now let us start actually modeling the specimen A2. Now if you go to the part here after you open Abacus and you write it down beam, and then let's write beam, and then choose shell, extrusion, and continue. Make sure that you choose shell and extrusion, otherwise this is gonna be not correct. Continue. Now I will be drawing, indeed I will be drawing um uh, the web first, and that web is from here to here, and by clicking on the line and drawing the web. Now by cancel procedure, then I need to think what is the height of that web, and if you look at the paper, the total height of the web H is 433. So you click there on add a dimension, and you click on the line, and you draw 433. You write it down in the dimension, and you enter. Now you need to draw the flange on the top. Now the width of the flange is basically BF, which is 102, which is so it is about 51 102. So half of the flange will be half width of the flange is 51. So if you look over here, you're gonna choose a line. You click from here to here, and then you cancel the procedure, and you re-click from here to here, and you cancel the procedure. Now, now you draw the the flange, and let's define the dimension. If you click there at dimension, you click on the line up, and its dimension is total is 102. Well, but we need half of the width, which is going to be 51. Similarly, you need to do for this case, you need to do it for the other flange, and you click here up, and 51. Now similarly you have to do here as well. You have too many options to do so. You can do indeed mirror, or you can redraw the lines over here from here to here, and cancel procedure, and then another line from here to here, and you cancel procedure. And then what you have to go, you go into add dimension, you click there, you go down, and it's 51 as well. And similarly you do for here, and you write 51. Now in this way you generate a cellular cross section, the cross section of the beam, which has a height of 433 and the width of 102. By clicking procedure here, cancel procedure, and you see read write done. Now we'll ask you what is the length. If you look over here, the total length is 1874, 1874, 1874. That is the total length. So it's 1000. Look again, 1874, and then OK. Here you generate the cellular beam. Now I would like to generate one more section, which is simply basically the circles. Now what we can do actually, we can generate a circle a different way. Let's think about one way to generate the circles. Let's look over here, create cut or extrude. I think create cut or extrude is good option maybe. Let's try it. And gonna ask you select the plane to extrude cut. I think this is a plane you need to create. And gonna ask you and the angular axis will appear vertical on the right whenever it is. For example, get you something like this. Now let's draw the circles. Now we need to draw the circles. Now let's start drawing the circles, and the issue here, we don't have the center of the circle. It's quite hard now to locate the center of the circle, because if you click on the create isolated element, you could, let's see, uh, let's try. Let's try if I think the best option is let's cancel procedure. I have another way. Yes. And let's create a dot lines here. So basically I'm gonna create a dottion points. Dottion points is a point where we're gonna collect locate the center of the circles. I think this is the best way we can do this. Now, where is the first circle? The first circle of the circle is located from here to here by d is 0 plus d0. Now it's 0. S0 to me is equal to S minus D, because from here to here is S, from here to here is S minus D. Now by calculating, the S here is 445.8, 445.8 minus minus uh, 445.8 minus D0, which is 342.5, 342.5, 342.5, 103.3. So it's 103.3. This is 0. Let's add into it half of D0. Let's add into it half of D0. So we will have a plus, which is 0 over 2, which is 342.5. 342.5 over 2 will give you indeed the distance between the edge of the I-beam into the center of the circle will be 274.55. Now if you look over here, let's create a deuterium point, and if you keep pressing, give you another options. Let's take offset from a point. Create deuterium point from a point. So we'll ask you select a point from which to offset. You need to select a point, this point, and you need to offset from this point to this point in z direction, and this is in minus z direction, of course. So you go to the third coordinates and you set minus 274.55 and enter. That you create the first deuterium. I need to have another deuterium actually from here to the second center. Now how we can do so is equal to S, and our S is basically 445.8. 445.8. So we create the same procedure. It's still activated, or we reactivate it maybe, and you click there for, and you write down again minus 44, what is it called, 448, 445.8, 5.8, 44, sorry, 5.8, and then enter. And one more, you click there and you write the same thing, minus 445.8, and you hit enter. And last one, so you have one circle, 2 and 3, last one, minus 445.8. Let's see. Let's hope it is symmetric. If you click there, sorry, it is 274.55. For some reason it's not symmetric. I need to see what is the reason. Let's look at the figure again. Uh, if you look over here, it's S. Again, S0 is S minus D. S0 here, S minus D. And 445.8, 445.8 minus D0, 342.5, 345. That's S0, 342.5. Seems as the length is not correct. The length is not correct. So let's correct the length. The length is not correct. So let's correct the length, because I'm gonna correct that. Okay. Is 0, so basically S0 is S minus D0, so it's 445.8 minus D0, 342.5, 342.5. So we said S0 is 103.3, so we have 1, 2, 4, 5 times 5 plus D0, 342.5, 342.5 times 4. I notice this is not correct length. The length indeed should be, based on the configuration, the length should be 1886.5. I think this is not correct, so I will correct it. Well, this is not correct because based on the dimension we've got here, this based on the dimensions, I notice that the length should, most total length should be 1886.5. So let's correct that. Now if you go here to the part, click on the sign here, you click on the sign here, you click again to the sign here, and you click on the extrusion. Oh, sorry, click on the sign again. Uh, where is extrusion? Let me see. Here we go. We click on the extrusion. So it is 1886.5. That is should be correct. Now let's make sure that the dimension is correct. Now if you click there, distance, you click on this line here, and then you click on this line, S274.55. You click again the distance, you click here, you click here. It's correct. So it's basically now it's symmetric. I think this is not correct dimension, and it should be 1886.5. Anyway, um, now we placed actually the dotium points. Now we can start creating um, the model, the circle. But before we carry on, you need to go save, and you need to find a place where you want to save. I will save it, for example, in the Tim. Let's call it cellular beam 2 for web post buckling. You choose a place where to save, but try not to save at all in a desktop, in your desktop or flash memory. But okay. Now, if you go again into this here and you keep pressing and you get you some options, take the create, cut, extrude, and then we'll ask you which plane you want to cut. You say this one, and you choose an axis, for example, this axis, this line, for example. Now let's create a circles, and now create circles by center and perimeter, and the center is here, and the perimeter I don't know, so let's click it, for example, here, one more here, click, and perimeter, any place. We will change the dimension, one more circle, and here another circle, and here. Now the diameter basically D0 is 342.5. It's 342.5. So that's the diameter. You unclick there to finish it, and you click on the dimension. So you click on the dimension, will give you radius. Now the radius, it's half of the diameter, and which will be 171.25, and said okay, enter. Similarly, you create a circle for this, the diameter, the radius, which is 171.25, enter, and similarly again 171.25, enter, and finally here 171.25, enter. Now we finished creating the circles, and now if you click on cancel procedure, and now you tell them to extrude to cut and say done. We will give you option, and you said yes, I need to throw all, and then done. In this situation, you create a circle in the cellular beam. Now I need actually to place stiffeners. Now the stiffeners will be placed over here. Now I'll create stiffeners. We will do that step by step. Now the stiffener for one place is which should be dimension of the height of the total height of the beam, and the height of the width, which is the total height, which is 3433, and the half of the width is 51. Now let's create. So if you go to part, let's call it stiffener. Sorry. Or we'll use a planar shell, planar. Be careful, okay? And continue. Let's draw a rectangle, simple rectangle. By clicking this rectangle, you click here, you click there, and now you're gonna put a dimension. Now you click on the dimension you have here, a dimension. The height is, as we said, is 433, so it is 433, and the width is 52, 51. So you cancel and you say done. Now keep it, we will use it later. Now let's go to material. In the material, we are going to use the material provided by the paper, which is simply 416. 416 megapascal. Now, I should say 416, it's Fy. Now, indeed, if you look over here, the steel has some hardening after elastic plateau, and there's some hardening. Now, I simplify the hardening in this way. I will assume that it's elastic perfect plastic. I'm not gonna include the hardening actually. Now in this model we can include the hardening, but in this model I'm not intended to include the hardening. I will assume that elastic perfect plastic material. If you want to include the hardening, you need to write elastic. You need to put the plasticity. You need to find Fy, Fu, which is Fu generally for normal steel is 510, and epsilon st is 2.5%, and the ultimate about 15%. Now let's go back. Let's create the material. If you go down here, the material, you go to material and you create steel, and then you go into elasticity, elastic. Now we're gonna assume the material to elastic modulus 210,000, and Poisson ratio 0.3. And I need to include the plasticity. You go mechanical, plasticity, and plastic. The yield stress is simply, as we said here, it's 416. And the plastic strain, if we need to represent elastic perfect plastic, so plastic strain should be 0 here. And then you said OK, and you dismiss. Now what you are going to do, if you notice here, you have a part, you have two parts, a stiffener and the beam. Now let's go into create section manager. Now create section manager. If you create, you will ask you what is the section you want to create. Of course I want shell section. Now since we have the web and the flange has different thicknesses, therefore we're gonna differentiate between the whip and the flange. So we go to the whip and you say continue and make sure this material is steel. We keep it as the thickness integration rule is same tone. And the value of the thickness we proposed here is 4.8. It is 4.8. And you said okay. We're gonna create something for the again the flange and you said continue and the flange thickness is simply is 5.6. It is 5.6 and then you said okay. Now because we have a stiffeners, I will also make a stiffeners as has a thickness. Now before carry on, I would like the stiffener to have material of elastic material because I'm not interested to study the stiffness. So I will go again to create material manager, create a new material. So it's a steel but elastic material. So I'm not interested in plasticity for stiffeners, and you go to mechanical elasticity elastic 210 123 and then 0.3 and then I said okay. Oops, I think it's not acceptable to invalid name thing because there's a space here. Okay. Now we can create for the section manager. Again, you create for stiffener shell homogeneous. You continue. Make sure the material is elastic, and make the stiffness, for example, is let's say 5 millimeter, for example, or 7 or 8 millimeter. Doesn't matter. Because a bit thicker stiffener, and then done. And you dismiss. Now let's assign each of the thickness into each element. So let's go for the beam. You go into assign manager, you create, you click on the web and you say done. Choose the one with the web, choose the middle surface and say okay. Now you go create again, you select the web, the flanges, top flange. Of course you click one here and you click into shift in order to multi selection. You click on the keyboard shift and then you click there, you click there and you click there and then you leave the shift and then you say done. You go into flange, keep it mid surface and say okay. Now let's go to stiffeners. Again you create, you click there, say done and we choose the stiffener sections and you said okay. Now we assign the thickness for each of these stiffeners and the width. Let's go to assembly. So make sure that is saved. Now I will bring the element into assembly. You go into create instance, bring the beam. I prefer to take independent on instance to mesh. And you said okay. Now I need to place the stiffeners into that beam here. Now in order to place it, need to bring it. So let's pick the stiffener here. One stiffener by one stiffener. So you click again here, click on create instance, stiffeners. Now make sure this is fine here, and you could make auto offset, doesn't matter, or an auto offset. It's fine. If it is very close or intersect with a beam, you click on the auto offset instance. Now it is quite far, so I can collect it. So now we untick here, and then you said okay. Now, just to teach you, if you want to zoom in and zoom out, you need to use the wheels you have here. The wheel in your mouse, if you move it right on left, and if you rotate it, so it's gonna zoom in and zoom out. Now, let's move this stiffeners into here. So I will use translate instance. You select the stiffener and you say done. So you want to translate the stiffeners into here. So let's pick up this point to match with this point. Now stiffness is placed here. And you said okay. Bring another stiffener, one more stiffener, and you said okay. The same procedure, you take the instance, translate, you click on the instance and you say done. I need to match this stiffeners and you need to put it here. So simply I will collect this point and you go place it here and will be placed in that place here. Now final here we need okay and bring in more stiffeners. One stiffener, sorry, one more stiffener. Be careful not to select a beam and done. You move it, you click there and you click on a stiffener and then done. You pick up the point, you pick it here and you said okay, and one more stiffener, you take the stiffener and you take okay, you move it, you click it and then you say done and you click on the nodes here and then you click on the node here and said okay. Similarly, I will add stiffeners in the middle as we said. One here, you click there, stiffener, then OK, and then you move, you click on the stiffener, said OK, and you click on the node of the stiffener, and you move it to the middle here, and you said OK. And last one on the other edge, you can rotate it actually by rotate the view, and then you can rotate around it here, and you cancel procedure if you want. Let's bring another stiffener. One and OK. You move it. You pick it up from here. Zoom it out. Say done. And you bring that stiffener. You zoom it in. You click there and done. Now you place the stiffeners. Now, indeed, this is stiffeners is placed on a beam, but they are placed on the places, but there is no defined interaction between the beam and the stiffener. So what you have to do, you have to make a tight contact between the stiffeners and the beam. Now this is a bit tricky one. So we'll do that step by step. First of all, let's place. Let's go into interaction. Now, what I want to do, I want to make uh, um, now we need to place this stiffener. That each of the stiffeners, these stiffeners that interacted with the top. Let's find another way actually, if we could find a way. Let's try this. Let's try. Let's try. So if you go to tool or feature, let's see, constraint. Oh, okay. Find the contact beer. Let's try this firstly. And the whole model and the contact beer found by the angle. Now I want to find a tolerance of 0.01 and then find contact beer. Let me see if we find a contact beer. Let's see if this is one. Okay, it seems No, we don't. It's not the one I'm looking for. It's a find a contact between stiffeners, not with. Yeah, it is not the one I'm looking for indeed. Let's cancel it. Cancel it. Let's do that one by one. So I will add the stiffener. Will contact the stiffener or tie the stiffener into the web firstly. So what you're gonna do? I will go into here, remove sorry, remove selected. I will click there. I will actually I will remove that here, done, and then remove here, done, and then remove here, done. Also I need to remove this one, done, and then I need to remove this one, done, and finally I need to remove this and done. Now let's try to see how we can manage this. Uh, my worry is that it's not gonna be interacted. Uh, okay. Uh, Now let's for a moment uh, remove the web and then done. Okay, cancel procedure. Now let's go to into constraint manager and then create and make sure this is a tie and then continue. Now click on the edge of the stiffener. Use for example surface. Click on the edge of the stiffener and press enter shift. Another edge, another edge, okay, and since it done, it will ask you what is the slave type. Okay, the slave. So it's basically connecting between the web, the surface, the stiffener into the web. So let's bring the web. I'm gonna click on the replace all. So we bring everything all. Now make sure you select surface and then you click on the web. So you said done. Ask you what color do you want to use, because if you rotate it a bit you'll have two colors surface. Of course, cancel here. Of course I want to use a purple because I want to connect this stiffener with the purple face. Sorry, brown face. So knock it on. Assume this is all correct, default, and set OK. You tied in the stiffener into the web. Now let's do the same procedure for the stiffeners here in the back, rotate, and the back here, rotate all the way down. Good. And then cancel T. Let's now remove these here. So you click on the remove selected, you click there, done, you click this one, done, this one, done, this one, done, I don't need it, and finally this one, done, and also the web, done. Now again we go to create tie and continue, surface, and select the edge of the stiffeners, other type of other stiffeners. Click and then Control Shift, click here and click here and say done. Now you need the web. So, replace all and then take a surface. You click there and then done. I need actually to connect the edge of the stiffener into the purple surface. Get the purple and accept the default and then OK. Okay, it's not finished yet. Um, so what we should do, indeed, we need to um, assign the top of the stiffener, weld it or tie it into the top flange. So how you do that? Simple, a bit simpler. So what you need, you click on remove selection. You click on remove selection, and then what you can do, you click on here and then done. Now let's bring that one manager as the constraint manager, create tie. Now select surface, and then you click over the top here, and then you press shift, you click here, and you click there, and you say done. It will ask you the slave sort type, the slave which is mainly the other the the top flange, and then you bring everything, replace all, and then you click on a surface, and you click on the surface of the flange, and you say done. Now what color? Of course I need the purple color to be connected between the stiffener and the purple color, and you say the purple, and that's accept the default. Let's rotate it back, and finally, oh, it's not finally yet. Well, let's connect the this is the bottom edge of the stiffener to the bottom flange. So again, we click on the remove selected, you click here, and you say done. Now again, you go to tie, select create another tie with this continue, you can select surface, you click on the bottom edge one, click on a on a shift, click, and say done. And then you bring all, and then you select surface, and you click here and say done. Of course you need the brown surface to be connected, and they said done. Now you accept the default. Similarly, we're gonna do for the other surfaces here, other stiffeners. um, you click remove selected, remove this one, and then done. Let's bring, create, continue, select on the surface, and then press shift, and you click all your edges here, and you say done. Now place all, and you click on the surface, and you click on the flange here, and say done. Of course you need the brown surface to be connected, and not the top surface, the bottom surface, and the brown, and you said okay. And let's rotate, because I cannot see the stiff bottom flange here. You rotate around here, so I want to remove, click here and done, and create tie, continue, get surface, you click on the the bottom edge here, shift, bottom edge, and you say done. Now what you need to do, you bring everything, replace everything, and then you get surface, you click over here, and you say done. You choose the brown surface, and you said okay, and all done. The connection between actually the beam and the stiffeners. So we assume it's a tie contact is like welded, and dismiss and click. Okay. Now what I want to do indeed, as you can see here in the figure, they said there's a load about 20 millimeter from the center to the load. So what I want to do indeed, I want to create a point where there is a load located here. So bring this down. I will do a partition. So let's go into if you go to assembly. Now I will create a node from here to here. I will make a partition actually to locate a lot more point load here. You go into this case and you keep pressing, and it's quite hard to know. So what I can do is before we carry on, uh, press X. I will place a datum point. So a datum point, if you click here and you keep pressing, choose the one which says offset from the point, and you take the offset from here, and it's in Z direction -20, and you set enter. Now you should locate here a datum point, but it's not concept here. It's not a point where you can point a load here. So you go here and you look to the one. Oh, okay. Select midpoint or datum point. So you click on this one and ask you select the edge to partition. You click on that edge. Will ask you select the point on the edge. I want that point where I created from the beginning with the datum point, and you create partition. In this way, it's gonna cut the edge between two pieces, so you can apply a load here and cancel. Now, before I carry on, we need to save. Now, first of all, since this is a web post buckling, therefore imperfection is so important. Imperfection is one of the most important things you have to add it into web post buckling to create web post buckling, or to generate um, to generate to have web post buckling. So you need imperfection. So how to do so? Um, I will I will name the model here. First of all, let's name the model. Actually, to create imperfection, uh, please go to my YouTube to my previous videos where I create imperfection on cellular beam. The same thing I'm gonna do here. Um, let's call it model 1. We keep it as a model 1, and then what you need to do, you go into step. Now you go on step manager, and you create a step. So more understanding of this, you need to go to my YouTube videos where you see some example on imperfection cellular beams. So we do the same thing here. So we keep it step 1. Let's call it buckling. Okay, keep the name buckling, and then you go to general, linear perturbation, and then you call it buckle, and then you say continue. Let's request for example 5 and increase this to 300 for example. Okay, let's see if it's possible to do it, and then okay, and dismiss. Now go into load. Go into load. What I want firstly, I now want to do uh, uh, a boundary condition here. Indeed, in order to make sure that I'm selecting the boundary condition correctly, which is basically the boundary condition should be over the top, over the flange, is not over the flange of the cellular beam, is not over the stiffness. So what I can do, I need to hide the stiffness. So I will go to click on a remove selection. I will hide this stiffener. Done. Hide the stiffener. Done. Hide the stiffener. Done. I don't see the other one. I will rotate it. Cancel procedure. And then I will hide that stiffener. And then done. I will rotate again. So, and cancel. So I will create, uh, I will be creating as a cellular beam. Indeed, you can do a symmetric cellular beam, but indeed, I'm not gonna do a symmetric. I will do in a bit different way. What I will be doing, I will go into here, boundary condition. I will be, I will create not buckling inertia. Select the displacement rotation and continue. I want to click, collect this point, this line, and press shift, and this line here to place a boundary condition. Rotate around, cancel here, only one time, and continue shift, click, click, and then done. What indeed I want not to allow in Y direction to move, so it's Y2, not to allow to move in X direction, so it's U1, and I don't want to allow to rotate around Z, so U Z. I want to allow to rotate around X, it should be fine. I'm not gonna, it's not gonna be rotate around Y. Now the only issue you will have is moving around X axis, Z axis. So I'll not keep this. We'll keep this off. I will let you know how can do, because if you run the model will move in X direction. So what I gonna do, I will show you now later, and then you said okay. So again, if you run the model, because if you double click here, because it's allowed to move in that direction, U3. Now what I can do, I can do the following. So if you create a partition in this point here in the middle, and let's do that. I will hide the stiffener here, hide the stiffener, and hide the other stiffener. Okay, and I will go again into create a partition here. I will click on that line. I cannot do the partition, so I will try to do it. Yeah, I will do another dotting point from here to the middle. So if this here about 20, you click there, dotting point offset from here into X Z direction about 20. So I will create that and click here, and then you click into partition of the datum point, and you click there, and then you click on the edge you want, and then you click here, and you create partition. Now what I shall do here, now you can place, now I create, you can place uh, by selecting here this in the middle point. It should be, this is in the middle, and then say done. Only unselect U3 because you're not allowing the beam to move in X Z direction. And say this, okay. Now that's all done, and you can bring all stiffeners. So you're gonna see that it's not allowing to move in the direction. Now I need to apply a load, so you click in the load manager and you say the create, and you go to buckling and select concentrated load and say continue, and you go here and you click in the point where there's 20 millimeter, there's 20 milli, yeah? And you say done, and it's in sorry, the distance is in y direction. It is -1, for example, just only -1 to have a buckling. That's it. You go now to mesh, click for example in a seed instance. Now select all to seed and say done. Now for example, let's say I want to seed in 20, and let's apply and see how much seeds we have. I think this should be fine enough, and then okay, and then done. And then you can do is click there and you click over, then done, and you mesh it. Now I need to know how many nodes I have. If you click there, query information, and you click on the nodes, you click there all and say done. Seems to me it's over 1000 node. So I have, it seems I have over 1000 nodes. Um, I have over 1000 nodes, so that's what I want. Okay. Now I will click on S and R. You click there and you choose, yeah, S for R, it should be enough. Linear, reduce integration, then shell element, and said okay, and done. Now what you have to do, you need to go here, sorry, file, and you go to set directory. You make sure you have to set directory. Please set directory in the same place where you save your model. I put in temp, so you save directory the same place where you save your model, and you said okay. Be careful, this is so important to remember. Now we run it. But before we run, we need to do an imperfection thing. And let's create, we go to file, and we go, sorry, the model, we go to edit keyword and model 1. Go to the end, you go here at the end, and you enter, you do star, I think it's called node file, and then U. I think so. Let me check. Uh, uh, let's see, perfection and double goes. Um, node file. Yeah, this is node file and U. So it is node file. Yes, node file, capital letter. So node file u. First node file u, node file, and then u and step. Or this name step. That's okay. Now let's go create job. Now create. Let's call this job is buckle. Okay, buckle, and then continue. Then okay, and let's submit. Take some time. I have no idea why it's taking time. Okay. It shouldn't take more time. Um, I think I need to kill the model. I think it's stuck somehow. Even I cannot kill it. Uh, okay. I think I need to close it and open it again. It's saved already. So I can already open it again. This and CAE dot CAE. Okay. Okay. Um, I will delete. I will delete it. Okay, I will create another name, but try to change the name buckling. Let's change the name to buckling. Then continue. Continue. Then okay. Let's firstly to check data check. Firstly, let's do data check. Let's do data check first. Let's see something. It's a mistake. It's not responding. For some reason, it's not responding. Let me do this one. Take some time. I have no idea why. For some reason, it's not responding. What's going on? Let's back again. Open it. Let's go here. Keyword model. Look, make it small letter maybe. Not file. No. Then okay. Run it again. Let's call it buckle 1. think there's a problem with the software. I cannot run it. Okay, anyway, um, I'm gonna stop here. I will make it at a part 1, and then while I check the problem, and then we'll continue.